And so this is my R1, and this is my R2 through 5. So this is R1. Okay, so now if I want to find the current through R1, and I need to in order to find the voltage across R1, I have to combine these two in series. So I have R1 through 5, all of them, is equal to R1 plus R2 through 5. And so when I do that, I get 10 plus 2.94. Oops. So I get that R1 through 5 is equal to 12.94. And that's ohms. Okay, so that gives me the circuit that looks like this. And this is just the resistance of all of them. So I'll just call it R total. So now if I want to find the current through R1, I can find it by saying I1 is equal to V total divided by R total. And R total, right, is now R1 through 5. So these two are the same thing. So I end up with V total is equal to 25. Let me just double check that it's 25. Yep. So 25 volts divided by 12.94 ohms. And so that I1, or it's I total, so, but I only care about the I1 right here. So I1 is equal to 1.93 amps. Okay, and now it's asking me, it wants to know the current in the 20 ohm resistor. Okay, so if I know, again, if I know if I go back here, if I know the voltage drop across here, then I can subtract that from my battery voltage, and that'll give me the voltage drop for each of these. And then once I know the voltage drop for each of these, that'll help me to find the current in the 20 ohm resistor. Okay, so now if I want to find V1 is equal to I1 times R1. And so that's equal to 1.93 times 10. So I get 19.3 volts. Okay, so now I know if the drop across here, this one is 19.3, then the drop, so if the drop across here is 19.3, then I know each of these has to be the difference, because the voltage here is the same as the voltage here is the same as the voltage here. So the voltage drop across 4.5 is the same as the voltage drop across R3 is the same as the voltage drop across R2. So to find that voltage drop, I'm going to say, so all I care about now is V45, because I eventually want to get here. So I don't need to even think about R2 and 3 right now. I just want to do R45. So V of 4.5 equals V total, so the battery voltage, minus V1. And so that's equal to 25 minus 19.3 and I'm left with, so that's equal to 5.68 volts. Okay, so now I've got the voltage. So they also ask me here, what's the voltage drop from A to B? And if I look back at my drawing, this voltage drop is before I get to this 5 ohms that's connected to the 20 ohms. So that means my voltage, my A here, is at this point right here. So this is A. Oops, and then my B is after the 20 ohm resistor. So that's going to be anywhere along here. So that would be here. That's my B. And so it asks for the voltage drop from A to B, and so I know that the voltage drop is going to have to be this 5.68. So this is actually the answer to number B, is 5.68 volts. And so that we found B before we found A. So now let's find the current in that resistor. The way I do that is if I know the voltage drop from here to here is 5.68 volts, then I have to find the equivalent resistance of R45, and then I can calculate the current. So I know the equivalent resistance of R45. I figured it out over here. It's 25 ohms. So to find the current, I take, so I, going through both 4 and 5, right, the current through them is the same since they're in series. That's going to equal V45 divided by R45. And that's equal to 5.68 volts divided by 25 ohms. So the I45 equals 0.0, no, I'm sorry, 0.227 amps.